Awesome. Okay, so we'll continue. In the last session, we spoke about list, right? Um, so what we saw was list was a linear ordered collection, right? Why we say order is every element had a position, right? So when we added first, it got added at first position. Then when you say add second, right, append we did, it got added at second position, right? And so on. So the index was default, 0 for the first, then 1, then 2, so on. We never had to give any index, and automatically it kept track of the order in which we are giving the value. So that's why we call it as ordered collection. Okay, and it is mutable. Mutable means the values can be edited, isn't it? So you could easily change the member of list. You can say list of 4 equal to new value. So whatever was at the fourth position would now be changed to the new value. So it is mutable, it is linear, okay, it is ordered collection, okay. Now we'll talk about another data structure, which is tuple. Now this tuple is immutable version of list, okay. So that means you can't edit it. So obviously, it doesn't have a lot of functionalities like list, okay. So, but let's understand how we declare it first. So T1, let's say I call tuple, and I say equal to simple bracket open and close, normal bracket. For list, we used square bracket, right? For list, we use square bracket. For tuple, we use simple bracket. Okay. So, so this is called tuple, and you can print the type. So if I say type of T1, and if you want to see the length, how many elements? So it would be length of T1, right? So obviously we don't have any value. P2, yes, P2. So you get tuple and 0. Okay. So this is how you declare an empty tuple. Now, if I want to add one member to the tuple, right? Let's say 2. Okay. Now, problem here is in mathematical operation also, if you have to add some number to the bracket, this is how we add, right? So in this case, Python doesn't know that it is tuple. It thinks that it is a list in a bracket, right? BODMAS rule bracket. So it thinks it's that bracket and you are giving an integer into it. Okay. So if you have to, this is one thing you have to remember here. If you have to use or if you have to pass one value as a tuple. So if you have 0, not a problem. And we'll see that if you're passing 2 also not a problem. But when you're giving 1, you have to give one extra comma. Okay. Now it will recognize it as tuple and size is 1. Okay. Because without comma, it doesn't know that it is tuple. It thinks it's a integer value. I have put it probably to do some kind of arithmetic operation. So it doesn't work that way. Okay. So we have to give this. Okay. Now, if you are giving 2 values, then 2 comma 2, because integer value will not have comma. It will have plus, minus, arithmetic operation. Okay, but it will not have comma there, right? So you give comma. Okay. So 2 comma 2, and then here if I run it now, it will show as tuple and 2 values. Okay. The reason why we use tuple is reading is faster. If you look at, if you have large volume of data to read, if you have large data to read, it is always better that you give as tuple. Okay. So reading through tuple is faster than list. Okay. So reading is faster. It's like when you know that you can't edit the value, it's like you have a expressway where you know that no vehicle can come in. It's, let's say, no one can get on. So your speed will be faster than, you have other roads merging into this. Right? So it is faster than list. Now, if I have to, okay, let me add few more values to it. Okay. Now you can iterate through this tuple for I in T1, exactly like we did in list, right? Absolutely no problem. Okay. What did I do? I did T1. So this entire thing is T1, isn't it? So entire thing is getting printed, right? And how many times? I in T1. So I in T1. So I will take first two, right? So I can say I, comma, hyphen, comma. Now when we run it, so let's see, 2 hyphen this, 2 hyphen this, 4 hyphen. So it's going to run 6 times. So this is how you can iterate through a tuple. So it will iterate with like number of elements in that value, in that tuple, and you can print the value, or you know, you can print the values as well. So another thing is, this is what we have seen, right? We have seen this in string also, we have seen this in list also. There's one more thing which is common, is the way you access the element. Okay, I want to access third element. So what will I say? I'll say print T1 square bracket. Okay, so to access it is square bracket. So whether it is string or list or tuple, access is always square bracket. You always access a member using square bracket, right? So I want to access third member. So I'll say 2, right? T1 of 2. Okay, you get 4. I want to access second last member. So I'll say -2. Then you get access to second last member, which is 8 here. Okay, you can also do say -2 colon. -2 colon means second last till the end. So we should get 8 and 10. Reading absolutely same as list. Challenge comes, problem comes when you try to write. So I cannot say T1 of 2 equal to 88. Okay, if you run it, it says tuple object does not support item assignment. Same error we got when we tried to do for string. So string and tuple are immutable. Your list is mutable. There's one more thing we can see here. Okay, when you say multiple values equal to T1, this is also called as packing. Okay, it's like you're packing a lot of things into one suitcase, right? So T1 is like a suitcase where you're packing a lot of stuff. You also have unpacking. Okay, so you take out and then put it in shelf, right? But you have to remember that when you do unpacking, you have to have same number of shelves. If you have 10 items to unpack, you need to have 10 empty spaces. Okay, you can't put it in more than 10 or less than 10 empty spaces. So what I mean to say is, I can see here we have 6 elements, right? So I can say A, comma, B, comma, C, comma, D, comma, E, comma, F, right? 6 elements equal to T1. Now you can print A, comma, B, comma, C, comma, D, comma, E, comma, F. And when you run it, oops, I have to comment this out, right? Okay, so see, this is your A, B, C, D, E, F. Okay, now if I do one less, okay, I say I don't want last element, I want only 5 elements. Okay, so it says too many values to unpack. So you have too many things to unpack, but you don't have space outside to put them. So while unpacking, it should exactly match. Okay, I cannot add, say, extra variable. So unpacking, sometimes we do, when you write, okay, so it says expected 7, but got 6, right? So let's say, when you are doing any kind of function, right, and you have fixed number of values to print. Let's say you are you are doing quadratic equation function, right? And quadratic equation will give you values for x, right? Or x, or what do you say? Let's say, hey, you have two variable function, x and y, for example, let's say. And okay, and your function is going to return values for x and y both, right? So since it's going to return two values, you cannot have two variables returning, right? So you can easily say a comma b returning, or instead you will return them as a tuple, and you can say the result of 0 is x, result of 1 is y. So maybe we might see some examples when you do NumPy. We can show you. So it is mostly done when you are building your own functions, okay? And there's some inbuilt functions generally in data analytics. We see, when your function is supposed to return 4, 5 values, 6 values, okay, so it will return as a tuple, and then you handle them. Okay, you handle them as 1, 2, or like you create a different variables. Okay, so maybe I can give you one easier example. Okay, let's say you are writing a function to perform addition, subtraction, multiplication, division, or 4 in one function. So you can return a tuple variable, okay, with 4 values, and later, okay, you can say a comma b comma c comma d equal to, and you can say a is the addition, b is the subtraction, c is the multiplication, and d is the division result, right? So you can do that way. So we do use the packing and unpacking many times, okay, mostly when you know that number of elements will not going to go beyond certain number, right? Let's say it will always return 4 values. So when you know that it's always going to be 4 elements, then why to use a list? You can use tuple, okay? An advantage of tuple is that even by mistake, nobody can edit it. Even if you want to edit it, you cannot edit it, okay? But there's one thing here which says that you can convert list to tuple, tuple to list. That means, let's say I have 6 values here, and now I want to add one more value to it. Okay. So now if I do, okay, let me show you what happens when I do T1 dot. When we did list dot, we got so many functions. Here you see our methods. Here you see we have only index and count. Only 2 methods you have. Index will tell you index of x, where exactly the value is in the tuple, and count how many elements are there, right? So index of 8, and I can say T1 dot count of 2, right? Okay, so I have to correct this mistake, right? So index of 8 is 4, right? 0, 1, 2, 3, 4. And number of 2's here are 2, right? So it gives a 2. So these are the 2 methods, inbuilt methods, which tuple has. But let's say I want to add a member to it, right? Now, first thing I just said, tuple will not accept. Tuple will not allow you to add. But let's say, it is business requirement and you want to add it. So it says, okay, if it is business requirement, then you have to follow one additional step. That is, convert T1 to list. The moment I say list of T1, just like we did int of str of, we are doing list of, your T1 has become list now. So now you see, all the methods of list is available, right? So you say T1 dot append, add a member, say 18, and then convert it back to tuple. Okay. So this is how you can actually make tuple use list function, but you have to follow the extra. Just to this that extra step is to make sure that You want to do it. It's not that by mistake, in program somebody has done it or you are doing it by mistake unknowingly. Okay. That extra step is like, yes, you know what you are doing. You want to do it. That's why you're doing it. Okay. So yeah, these are the main things in tuple. As I told you, it is faster, so we prefer it in reading. If you have to do looping, okay, then tuple is preferred over list. But obviously, if you want to store data, then list is preferred. Now, one more thing you have to see here is, let's say a equal to, I gave 5, 8. And here I say b equal to 4, 88. Which one do you think is greater? A or B is greater? So which one do you think A is greater, B is greater? So in tuple, we always compare the first element. Okay.
Okay.
So first element is 5 and 5, 4. So A is greater. Okay. Now let's say if both the elements are same, then we compare the second element. Okay. Then if first are same, then only we compare the second element. Now the second element, okay, so let's do 4 here and see the output. A will be greater, 5, 8. Now if I make it 5, okay, it doesn't matter what you have, okay? You have 4, you can have, multiple values here. But it doesn't matter because you always compare the first element. Now if first element is same, now you compare the second element. Okay, so 88 is bigger, right? So that's why it printed B. Now if second is also common, then it's going to check the third one. So this has greater, right? In third, it doesn't have a value, it has a value. So B is greater, right? Now if both has exact same values and same number of values, only then it will say both are same. Okay, so for both to be same, they need to have same elements in same order. Okay. Did we do a deep copy and shallow copy in list? We took
No.
No. Okay. Let me quickly see what all things we did here just to make sure that. So we did len, we did index, upper lower. No, upper lower is not in list. Oh, we have not done list completely. Yeah.
Yeah, I think you just introduced it and you said we'll talk it
Yes.
next session.
Oh yeah. Because I remember doing methods and that was for string. So we did string methods and then introduction to list. Oh yes. Okay. Okay. We'll do list now. So this is what about tuple. Okay. This is what tuple is, and this is very simple. Okay, because it is only for reading, so it does not have any extra method. Okay, but you can convert into list and use all the methods that we're going to talk about now. Okay. So coming back to list here, we know. So list, we know it's a linear collection of linear ordered collection, and I can take an example L1 equal to square bracket 4 comma 6 comma 8 comma 10 comma 12, right? Now indexing we have done, right? Forward and backward indexing, exactly same as string. We'll look at some functions or methods, okay, which are supported by list. So let's say I want to add an element to list, okay. Now to add an element, there are two ways to add it. One, you use append, okay, and then you give the value. Let's say I want to add 55. So when you say 55, we are adding at the end. Append will always add because order collection, right? So you know what is first, what is middle, what is last. Okay. Add element at the end. Okay. So print L1. So you will see element is at the end. You can also use insert. Okay, so you can say L1 dot insert. Okay. Now insert, if you see, okay, now I'll show you. The moment you see index, see this is the suggestions it says. Okay. So first one is self. Okay, and we ignore self. I'll tell you why. Okay, we'll discuss about self when we do class and objects. Okay, self indicates that it's an object level function or a variable. Okay, we are using function, so it says it's an object level function. It's not class level. So we'll see there are some which are at class level and some which are at object level. So we'll see when we do class and objects. So for now, you ignore self. Okay. So apart from self, all this function will have self. Apart from self, what all options it accepts? It expects that we give in index and object. Okay. Object is a value that we want to save to this list. And index is the position at which we want to save. So let's say I say insert at third position. So it becomes 4, right? I give index 3. Index 3 means fourth position. So you already have 1, 2, 3, 4, or actually this is the latest one, right? So 0, 1, 2, 3, right? So we are saying that it should be at 10th value 10 should be replaced with 90. So what happens? 90 will go at this position and everything else will shift by a place. Let's see here, 2 dot. So that we know which print is printing which line. So it says 2 dot 4, 5, sorry, 4, 6, 8, and then 90, because we said 90 should be at third position. Okay, so before that position, everything will be untouched, and after that position, everything will move one step behind. Now, again, I can say 3, and let's say I put 70. So right now 3 is 90. Now 90 will become fourth, and third index is 70 will go. Okay, so you can add values using insert or append. Append accepts only one value, which is the value that you want to add, and always adds at the end. Insert, you can decide which position you want to add, right? If position is important for you, then you use insert, otherwise we use append. Okay. So just like we have two values to add values to it, we have two methods to remove value. So you can say L1 dot, sorry, L1 dot, you have, okay, remove. Remove is expecting object. That means which object, which value you want to remove. Let's say I want to remove 12. So I'll say 12. Okay. Now you can print list. Okay, I'll call it as 3. Okay, and you run it. So you see, you get, okay, 12. 12 was here, it's gone. 12 is not there. Right? So now let's say I give 120, for example. So it gives error, not in the list, X not in the list. So what it says, since giving us error, okay, we need to check if the value is there or not, when it then remove. So for example, if somebody says, you ask the user which value you want to remove, says 12 I want to remove, or 120 I want to remove. So first you check if element in L1, if element in L1. So this will give you true or false, that element is in L1 or not. Okay, so in is called membership. Okay, so in for it has different role to play. With if it has different role to play. Okay, so always it will, right side is the bigger set, big, or maximum values collection, and left side will be your single value. Sometimes we can have multiple values also. In for loop, we'll see when we do dictionaries, we'll see it can return two values also. But so what it says is left side will be always smaller, less than the right side. Right side will have all the values. And so what I'm saying here is I'm checking if element in L1. If element in L1, only then you remove. Otherwise, else you say print element doesn't exist. So this is another way, one way to check, right? Element doesn't exist. 120 doesn't exist. Element in L1. Okay. So is element in L1? This is how you read. Is 120 in L1, right? It's not there. So it says false. False. So it doesn't execute. It comes here and executes. Second way is that you find the index, right? So now if I say L1 dot index was there in tuple also. So I say index of element. Okay. Now I go and I say print index. Okay. You run it. Okay. Exit code 1. Why? So because 120 is not in the list. Correct? So you can't even find the index. So you say count. Count will tell you how many elements are there. Now, if count is 0, right? If count is 0, then you know that element doesn't exist. So, second way is you can say if L1 dot count element, okay, equal to 0, or you can say is less than 1. Right? You can do 0 also, you can say, or less than 1 also you can say. If the count is less than 1, then you say element doesn't exist. Right? And if you give 12, you run it. Okay, it says element doesn't exist. Why does it say element doesn't exist? Can you hear me, Prakash?
Because we removed it.
Yes, exactly. Just a quick test. So yes, we just removed it, right? So we are checking it after removal. Yes. So this is how you can use count and index and remove. Yes. Then second way to remove is called pop. Okay. So I'm going to print L1 and I'm going to show you pop here. So L1 dot pop. See, pop takes index, right? Remove takes values. So if you want to, if you know which value to remove, you use remove. But when you don't know which value to remove, but you want to remove an element at a certain position, that's when we use index. Now, index pop, this is the third list, right? I want to remove, let's say 70. So position of 70 is 0, 1, 2, 3, right? So I'll say pop3. And then you can run it and see. Okay, I'll say 4. 4 should be without 70. See, there is no 70 here. This is how you can remove
I have a question. So,
Mhm.
so the list cannot have duplicate values?
No, it can.
It
List
can?
will have. List will have.
Okay. In
List
that
will
case, if we need to remove something, we cannot use remove, right?
First occurrence.
Oh, first occurrence. Okay.
First occurrence. It's always about first occurrence. Okay. So let's say index we used here, right? Okay, we change to count. Okay. So now let's say, okay, let's manually add some values. And you see it doesn't affect anything. Yes. So now I want to find index of 8. Okay. I think there's one question in string. Same concept in string also has it. Okay. And I want to remove using one loop. I want to remove all the occurrence of 8, for example. Because if you do remove 8, okay. This is 4, right? Now let me say 5 here. And I will say print L1 dot index of 8, let's say, before 5. It says 2, 0, 1, 2. Other 8 is ignored. Okay. Now I want to find index of all the 8. Then how should I do? Okay. Now again, if you see the index, okay, L1 dot index. So it has object, which is mandatory. There are start and end. You see dot dot. You can click it, you can see the entire thing. There is something called start and end. Okay. So start and end means, okay, you want to check within which range of values. So by default, start is 0 and end is your len minus 1. Okay, that means search from 0 to the length. Okay, so when you're searching from 0 till the end, so this is like this. If I don't know if I told you this example, this is example generally I use. If I tell you find, okay, say I've lost a pen, can you find it? So it gives you a meaning that there will be only one pen, isn't it? Right? You will, if you find a pen, you'll give it to me, you'll stop searching, right? You will not search for more because I'm trying to find. So same thing, index, I'm trying to find the element. I said, yes, I found position is 0, return, position is 2, returns and stops. So, but I want to find more. So I have to tell you that there are 2 pens. Then only you'll focus on 2. So here, if you see index, okay, okay, let's do this. Print index, we have 8, right? So let's run it again and see. So you have value at 2, right? Because we set 0 to end of this. So we have 3 plus 3, 6 plus 9. So till 8. So between 0 to 8, find an element for me. Or did I say print? Okay. No, it should be in index here, not in the print. Okay. I'm saying find 8 between 0 and 8. Okay, element is 8 and 0 and 8 are index. So I want to find within those 2 indexes. Now, I know that element is at to second position. What will I do? Next, I'll give 3. If you give 3, now it will try to find this from this third position. Okay, so from here it will try to find 8. So it finds at position 5. And this is 5th. You might have one more 8. So now next what you have to do is, did I give here itself? No. Let me remove it and yeah, I added in tuple. I should add in list, right? So, so now it says 5, right? Because 5th is the second. Next time what I have to do is I have to say from 5 to whatever it is, 10 or 12, right? It's no longer 8. Let's say I put 12. So now I'm saying from, okay, 5 is already there. So I have to say from 6, from the next position onward. Now it gives me that it's at 8th position. Now I'll say give me 9, from 9 to 12. Now it gives me the 10th position, this one. Now I'll say 11. Okay, error. Okay, that is index 8 is not in the list, error. Right? Between 11 and 12, it is not there. So it would always give you first occurrence. Now, if I want to print all the occurrences, I'll have to write a loop because count will tell me how many 8 are there. Correct? So here I go and I'll say for I in, okay, range L1 dot count of 8. So count of 8 will tell me how many times I need to run the loop. Right? And what I'll do before I run the loop, I will say A comma B, or I'll say S start comma end E equal to 0 comma len of L1. Okay. And now here I will say start and end. So now you saw that, right? We are not changing end, we are changing the start value. So the start value, okay, so I have to find the index first, right? So let's print it outside. INX. So INX is index. So you print INX. And I want to print in same line. I don't want to print in different lines. So I'll say end equal to comma space, right? I want to print in same line. And once I'm done, I will say print blank because I want to give a break a line. Otherwise, this print will also print in the same end of the line, right? So after loop is done, I just want to give a blank line. Okay. Now you see, INX, if I run this, it will print same value multiple times, 2, 2, 2, 2, 2, 2, 2. So what I have to do is, once this is printing 2, now I have to change the start value, isn't it? Or rather, after printing, I have to change the start value to what? INX plus 1. That means if you found at second position, second index, now search from third index. Okay, you found at 8th position, now search from 9th index. So S is changing every time, just like I did manually, I showed you, right? So now you see, it will give you all the position where the value is. Okay. So this is how you can find, do count and index are helpful. Okay. Important thing which I asked you was the copy thing. Okay. Now let's say you have L1 and I say L2 equal to, there are two ways to copy L1. Okay. L2 equal to L1 and L3 equal to L1 dot copy. There are two ways to copy. So let's say I print all the values here. I'll say after copy and I'll say this after editing. Okay, I'm going to print L1 equal to L1, right? Now I'm going to print L2, L3. This is L3, this is L2, L2, L3. So you see all three values are same, right? You expect them to be same, isn't it? Because we did copy, so you expect them to be same, isn't it? Now let's say I make some changes. I make some changes to L1. L1 dot, let's say I say append, and I add 101. I make some changes to L2, append 102. And I make changes to L3 also. Also, I'll follow the same practice. Append, and I'll say 103. Okay. Now we'll copy and see the difference, and you tell me what difference you notice. Do you notice any difference at all? And if you notice difference, tell me what difference you notice. You find any difference?
Yeah.
What is the difference? And why is the difference?
So L3 did not get the appended values from L1 and L2.
Sorry, I didn't get you.
L3 did not get the values appended in L1 and L2. I mean in L1.
Yes.
Yeah, because L3 is copying from L1.
Yes. Correct. So, so what is happening here is, this is like, photocopy. No, this is not photocopy. This is actually copy is photocopy. We call it as shallow copy, okay? And this is called deep copy. Okay, it's like, how to remember is, okay, like giving another name. And this is like doing photocopy. This is how I remember. Okay, so see L3, L1. So let's say I have a list, I have a paper, okay, and I have some content here. I go to a photocopy shop, I ask them for a photocopy. Okay, so let's say we have notes, right? And we want to share the notes. So I have the notes, so we go, we take a photocopy. Now you take the photocopy, I take the original, and we are different, right? I can write my own notes on it, you can write your own notes on it. That is not going to impact anything. Correct? That is like photocopy. The moment you take photocopy, they are same. L1 and L3, L1 and L3. The moment you take photocopy, it's exactly same. You don't look for spelling mistakes in photocopy, isn't it? They're exactly same. The moment you take photocopy. After that, I do whatever, you do whatever. I add 101, you add 103. We are making our rough notes. They are no longer same. L2 is equal to is like saying, okay, we have a note, we book, we say, let's share it. So that's another copy. Sharing means what? Now that becomes your notes and my notes. Your notes and my notes are referring to same document. So if I make some changes, or if you make some changes, both will be reflected. Because it's the same copy. So what is happening here? You have a list in memory, right? You have a memory location where the list is stored. You are creating one more index, one more reference to the same memory location. Memory location is not changed. So you have a house, I call it B1, you call it B9. So though you call it B9, I call it B1, since the same house, whatever you do, whatever I do, both will be reflected in the same house. So deep copy is equal to, which means naming or referring same value, same list by another name. Deep copy is creating a physical separate copy. You're not shading, you're creating a separate copy. So the moment you create separate copy, they are different, right? This will have different memory location and the first list will have different memory location. So if L3 makes change it will be in the new memory location. And if L1 makes change it will be in the old memory location. So there is no connection. So L3 does not have 101 or 102. But your L1, see L2, since we did M101 to L1, L2 also got 101 first, not afterwards. Isn't it?
Mhm.
So this is called shallow copy versus deep copy. So both have their own advantage and disadvantage, right? You need to know when to use what. If you want to refer same, you have to say equal to. Okay, but you say equal to, but you actually mean to have a different copy, then your program will go wrong, isn't it? So you need to know what you're doing and do that. Sounds good?
Yep.
Okay. So this is one important concept. I wanted to. Okay, so there are a couple of more functions. Well, let's do it. Okay. So you have L1, right? And I'll say L1 dot sort. Okay, the moment you say sort, it has two options, key and reverse, right? So in integer, you don't have to give key, it knows that number it has to sort. So by default, it will sort in increasing order. Okay, so if you say L1 dot sort, L1 is changed. So now when you print sort and you say L1, see 0, 4, 6, 8, increasing order.
Mhm.
You can say reverse equal to true. The moment you say reverse equal to true, it will sort in decreasing order. If you want to sort the list of values, use sort. Okay. Or if you want to reverse, you don't want to sort it. I'll do it reverse here. L1 dot reverse. It will simply reverse the value. The first will become last, last will become first. Okay. So see, it was 4, 6, 8, 9, no, L1 is this one, right? So it became 102, 101, 55, 8, 0, 8, 12, right? Up to 4, reverse order. So this is how you perform reverse. Yes. So with that, we finish our list. Okay. So I was thinking to do a mini program. Okay. We have this concept of stack and queues, isn't it? So stack is when you have last. So when you do stacks of books, the first book that you put and second book on you put on top of that, third you put on top of that's how it becomes stack, isn't it? So when you have to read it, you can only take the last book that you have put.
Mhm.
Right? So the stack is called last in, first out. And when we talk about queues, so the first person to enter into queue is the first person to come out of the queue, right? When you have a queue for movie ticket, the first person in the queue will get the first movie ticket, isn't it? So we call it as first in, first out. So you can implement a stack and queue. When you say stack and queue implementation, you only have to do, add an element and remove an element. So in stack, if you have to add an element, so stack, okay, you always add at the end. So you will add using append. Books are getting added at the end only. The first book is down. But when you remove it, you have to do pop -1, isn't it? So if I enter, let's say if I enter in first list, if I enter 1, 5, 8, 9, 5, let's say 7. So I've entered 1 first, 5 then. So 1 is there, then 5, then 8, 9, 7. Now I want to read the value. I cannot access any other value except 7. If I have to access the value, I have to go through 7, 7, 9, 8. So I can only take out 7. So 7, what is the index of 7? -1. So pop of -1 will be able, is using what? You will be able to remove the value. FIFO is first in, first out. So add is append. Remove will be pop of 0. So always the first element in the list will be out. Right? So this is how you implement stack and queue in list. So maybe you can write a program. You can write a program to add members to the queue and remove. So user will say 1 add, then you add. So you can add at the append. You can try this. You want to store multiple values. See, we did one program where we added 10 numbers or 5 marks of 5 subjects. Now, marks of 5 subjects, every time you add in a loop, it's lost, right? Because some, so let's say if I want to say add 5 numbers. So what we'll do from the user, let's say, from the user. So when you have to run, you have to say for I in range 5, right? And you will say num equal to int of input, enter the number. Okay. So what happens? It'll ask you one number, then loop will repeat second number. If I want to find sum, I have to define a variable here, sum equal to 0, and then I need to save the value num here. And then here I can say sum is sum. Okay. Now when I run it, enter the number 5. Again I say 5. Again I say 5, 5, 5. So you get 25. Right? So what is happening? Okay. Because I need to run 5 times. One option is you put input 5 times. But that is not efficient way, right? You want to do it in a loop, right? to get 5 values. And then because every time the loop is run, num is replaced with new value. So if you want to find sum, you have to replace, you have to save into sum before another value is added to it, right? So you have to put it in the sum. Now, if I want to display all the values, you can't display all the values. Why? Because num is keep on overwriting. If I print num, you'll get the last element. So in this case, we can create something like nums numbers equal to list, and then you can say here or after sum nums dot append, right? Nums dot append num. Now you have all the values here. So I say 2, 4, 6, 8, 10. Right? Sum is 30, values 2, 4, 6, 8, 10. So you are using list to store the values as well. So using list, you can save values. Okay. So with that, we finish list. And you have the assignments in list, try to complete them.